Hey guys, welcome to my channel. My name is Lokesh. I work as a lead architect. So in this video, we'll continue our learning on AI where we learn together. So this is a part of the book reading series where we would be reading snippets out of the book. We will not be going through all the chapters, just one chapter because we don't want to get copyright claims on our content. So we'll continue on the previous or from previous book reading episode where we talked about LLM Twin. So today we're going to discuss about some of the architectures that are being proposed inside the book and some of the pitfalls of the previous architectures. We will try to understand that what are those pitfalls. We will not take anything for granted in the sense that we have to have our own reasoning. Otherwise, you can read as many books as you can, but you'll not get any value out of it. So without further delay, let's look at the screen and we'll go through that. So as we can see here, the authors have tried to maybe list down some of the old architecture patterns for ML and what is the new architecture pattern that they are suggesting. We'll also look into that. So let's go through this. So you can see here, they're saying, I'll just quote the book now. Maybe I'll go a little fast. You can observe that the architecture pattern, the most ML, it is based on monolithic batch architecture that couples the feature creation, model training, and inference into the same component. By taking this approach, you quickly solve one critical problem in the ML world: the training serving skew. The training serving skew happens when these features passed on to the models are computed differently at starting, and this is the features. So this is the architecture that they're talking about. Uh, so in machine learning, you have three important components if you want to have a productionized system. One is you need to have features, you need to train the model, and then obviously the model should be able to make predictions or inferences out of it. So let's probably, before even talking about whether this architecture is good or not, or what are the, drawbacks of using this architecture, let's try to understand these three components or concepts. So I already, did some prep for this video. So not only for video, since we are learning, so I already, was going through these this section rather from the book, and I did some research on this, and obviously as you can see, most of the research I've switched from Perplexity to Gemini Advanced, since I'm using a paid subscription, and I started to like it, and trying to get habit to use Gemini more as compared to Perplexity, but that is another topic. So let's see what feature. I was actually, going through it before, and as you can see, I did some research on Gemini. So out of, I think there are three important terms that we need to understand. One is features, one is model, and the third one is the prediction or the inference. So model and predictions, I think they are self-explanatory. You develop a model where you feed in some data and it will predict based on that. So when you're training the model, you are basically making sure that the predictions are correct. And when it goes to the production system, you just have to feed in the data in real time, and it should be able to get the answers quickly, as in when you supply the questions. But features is somewhat, I'm not aware. Features can mean a lot of different things, but in the context of machine learning, we need to understand what it is. So you can see here it says that think of it as, if it is a house, the features are things that the number of bedrooms, square footage, location, and age. These individual characteristics provide insights that help a machine learning model predict the house's price. For example, types of features: numerical, categorical, binary, ordinal, text, image. So feature is mostly related to data. So the more data we have, the more features it could have. And the more features we have, the better would be, I think, the model training would be, which means the better would be decision making process. Why features matter? Data representation. Features determine how the data is represented in the ML algorithm. Good features capture the essential information within can understand. Okay, so featuring is an important part of building ML architectures. What is feature engineering? This is the process of selecting, transforming, and creating new features to improve the performance of your ML model. It often feature selection, feature extraction, feature scaling, choosing the most relevant features from your data set, creating new features from the existing one, normalizing or standardizing examples of features in different applications. Spam detection features might include the presence of certain keywords. Okay, so maybe it's an extension of explanatory data analysis, which is EDA, where not only you explore the data, but you also look at some different aspects of data, or the context of data, specific uses and features of language. You use communicating machine learning model by selecting memory. You can unlock the potential for data and build more insightful models. Okay, let's come back to this window. So this architecture says that there would be training data, there would be inference data, whatever you have first and create features and a train model, and the model has to be stored in model. So this is how you would be able to use the model, and then you can make features out of it, model weights, model weights, predictions are made. So let's pipeline first. And once you optimize it, that is where the first start data, and just you will be able to use it with live data, and then you can make predictions. This architecture, which is like the same code as the training service closure, is sort of default. This pipeline was fine when working with small data. The pipeline runs a schedule in batch mode and prediction consumed by third party, such as the dashboard. So there is another important term that has been thrown around, training serving queue. So let's try to Gemini it. What is training serving queue? I think training serving is the critical issue in machine learning that occurs whenever there's a mismatch between how you handle data during the training phase and how you handle the data during the serving of the phase can lead to. Okay. So what I understood from this is that since the features in this type of architecture are coupled with the model logic, that means the feature of the training data would be same as for the inference data. So there could be very little chances of deviation from it because uh, you're not dealing with, first of all, big data, and also the code will run every time you're trying to generate features. So it will generate features in runtime probably, and that is the reason that the training serving queue is not an issue in this architecture, which makes sense. Because what would happen in other cases is that you create features on your training data, but what if your production data is entirely different or somewhat different to the data that you trained on? And in those cases, the features will differ, and that could lead to you know unsuccessful predictions out of your ML architecture. And that is why, since everything is coupled, this is called a monolithic architecture. But there are certain drawbacks associated with that. Features are not reusable. If the data increases, you have to refactor the whole code to support PySpark. It's hard to rewrite prediction module in a more efficient language such as C Sharp, Java, or Rust. It's hard to share the work between multiple teams. It's impossible to switch to streaming technology for real-time training. So most of these are self-explanatory, so we don't have to really look into it. So this is mostly for batch systems. That is, you make the predictions where the predictions are not required on runtime. Okay, so that is something. And what could be an example of batch processing predictions? Maybe let's try to find out. Give a couple of examples from batch processing ML architectures. So let's see what it returns. A telecom company wants to predict whether customers are likely to churn. Okay. Fraud detection in financial. So something that goes on at the back end. Okay. Now let's read forward. In figure 1.3, we can see a similar scenario for a real-time system. So real-time system is where need the prediction at the at real time rather. So what could be example of real time? Again, we'll look into this. Give few examples of real time predictions. I've not written the entire thing because it would have the previous context. Fraud detection, financial transactions, as credit card transaction occurs. System has various features to instantly assess the likelihood of a fraud. Okay. When you browse an e-commerce website or past behavior. Okay. So real time, the term real time here refers to generating predictions on the fly. So here what they have done is they have taken the predictions out, but features and model are in the same box. You have the training data, you create model out of it, and then so user would request whenever user logs in, or maybe it could be any other system wherein the request comes in. So you create features on the fly, and then it would give you the result. So this ties to our understanding on the monolithic architecture that features would have to be created on at runtime. We can see a similar scenario. This will introduce another issue in addition to what we listed. To make the predictions, we have to transfer the whole state through the client request. So it's something completely possible. Okay. It's never been made so instead of simply passing the must be values into the name gauge, send once for picture. So as the client might must understand how this is achieved, and it's tightly coupled with the model service. Stateless. Whether the term include their status. So why is stateless? Because we are not seeing the data that is coming from the request under the reason. And why is coupled? Prediction and model service coupled. Because you're not seeing anything, you're seeing uh, your data. And that is the reason. So let's try to Gemini it. Why model serving and prediction for a real time chair which is stateless are said to be coupled. I'm not sure whether this question makes sense, but let's see. In real-time stateless models are often said to be coupled because they're tightly integrated and work together seamlessly to deliver. In a stateless system, the server doesn't store any information about past. Okay, this means that for every incoming, the server needs to perform the prediction on the fly. This necessitates a tight coupling between the model serving its roles and managing the model and the prediction component. Okay, got it. Low latency real-time application demand into very quickly often to achieve this the model serving minimize and tightly integrate to minimize any. Okay. So the main reason they are coupled is because the model serving and the prediction component have to run or operate on the fly. That's why it is tightly coupled. Think of a vending machine. So this is something that I like about Gemini, that they give you analogies from real world. When you press a button to select a product, the machine needs to immediately dispense the item. The mechanism that recognizes your selection and the mechanism that delivers the product are tightly coupled to provide a seamless and instant experience. So that is why this is coupled. Our problem, yeah, let's continue with reading. In conclusion, our problem is accessing the features to make predictions without passing our client's request. Is accessing the features to make predictions without passing, okay, for example, based on our How can we predict the recommendation solely based on users' ID? Remember these questions as we will try to answer them shortly. Ultimately, on the other side, Google Cloud provides a production-ready architecture. Unfortunately, even this is very complex and not intuitive. What is this? Yeah, this looks a little overwhelming. Data analysis, data validation, view store, offline triggered, model registry, prediction service. You will have difficulty understanding this is also it is not sure understand how to start. Yeah, this really looks complex even for me, even to me, not even to me at least, because I would call myself as a beginner or somewhat, between beginner and intermediate as far as ML and AI not technologies are concerned. The following image is reproduced from work created and shared by Google. So I think we'll limit our discussion up till here, and maybe the solution to both of these architectures would be the FTI architecture, which we might be able to cover in the next section. So I'll try to take a leave now. Hopefully this was uh, useful for you, at least since I had already done some study on it, and now while I talk and explain the things, it makes the things more clearer, especially the real-time architectures, the batch architectures, the coupling, the decoupling concepts. So hope you enjoyed this video. So if you have anything to recommend, please comment below, and we will meet in the next video. Till then, take good care of yourselves. Thank you, guys.